Welcome back, my wonderful set of students, to another mathematics session. We will just pick up from where we left off the last time. And the last time we actually looked at how we can solve simultaneous equations using the matrix method. Now, we did not get a chance to really work so many questions as we would love to. So we want to work some more questions as it relates to solving these equations. All right. So let us just remind ourselves of the steps that we need to carry out when you're solving simultaneous equations using the matrix method. So step one, we need to write the equations in the matrix form, which is AX equal to C in that form. Step two, we need to find the inverse of the 2 by 2 matrix. We need to find the inverse of the 2 by 2 matrix. And you'll notice that from time to time I will say the inverse of the 2 by 2 matrix, because it doesn't necessarily mean that the matrix that you're going to be working with is matrix A or matrix B. All right? It could be matrix C, it could be matrix D, but you're going to be finding the inverse of the 2 by 2 matrix. Step three, we're going to now multiply both sides of the equation by the inverse of the 2 by 2 matrix, which we would have established in our last session that the multiplication on the left hand side of the equation is not really necessary, right? You don't need to show it because that is just taking up a lot of time, because we already know that when I multiply a matrix by its inverse, I will end up getting the unit matrix. And the unit matrix times, say, a matrix C will give you back the matrix C. So we already know what the answer will be when it comes on to the left side of the equation when you multiply by the inverse. So all we need to do in the third step is just to multiply the constant by A inverse, or the inverse of the 2 by 2 matrix. So let us now quickly look at a question, and then we can work a few more questions. Now, with the objectives that we want to cover here, it says solve simultaneous equation using matrices, and we're going to solve matrix equation involving equal matrices. Okay, so we will see how we go about doing that. So let us look at a question, right? So the question that we want to look at here is 2x plus 3y, and that is equal to 11, and 4x plus 2y, and that is equal to 10. So we want to solve that pair of simultaneous equation, but we must use the matrix method with it. Now, step one, write the matrix in its, write the equation in the matrix form. So we're going to have to take out the numerical coefficient of the variables, which would have been 2, 3, 4, and 2. Then we would have x and y, and this is now equal to 11 and 10. Remember that the last time we looked at that, we said that the matrix form would have been AX equals to C. That's the matrix form that we're talking about. So notice here, A is the 2 by 2 matrix, and the elements inside there would have been the numerical coefficient of the variables. X is a 2 by 1 matrix, and that is due to the fact that we're only solving for two variables, good, X and Y. And then C is your matrix here, which contains the constant term. So this now would have been written in the matrix form. Now, what's the next step? The next step is for us to find the inverse of the 2 by 2 matrix. The next step is to find the inverse of the 2 by 2 matrix. So let's go straight ahead and work out the inverse of that matrix. Okay, so we can take it up here. So this now would be A inverse, and A inverse is 1 over the determinant times the adjoint. 1 over the determinant times the adjoint. Now, it's 1 over, this is going to be 2 times 2 minus 3 times 4 times the adjoint. Remember, the adjoint is that we're just going to fit the leading elements. Now notice the leading elements are the same, so it really doesn't matter right now. So what we're going to do is to just multiply the non-leading by -1. So that now changes sign there. So we end up here with 1 over, this now becomes 4 minus 12 times 2, -3, -4, and 2. Good? Now, 1 minus 2, sorry, 1 divided by 4 minus 12 will end up with -1/8. This now becomes 2, -3, -4, and 2. -1/8. All right? Now, here, this matrix here now represents the inverse of the 2 by 2 matrix that we have right here. It represents the inverse of the 2 by 2 matrix that we have right here. Now, students, step 3. We need to use the inverse here to multiply both sides of the equation. We need to use the inverse here to multiply both sides of the equation. But from what we have looked at in our last session, we realized that if I use the inverse to multiply this side, which is the left-hand side of the equation, then the answer is just going to be my variable matrix here, which is x, y. Good? That's what we established in the last session. So all I need to do now to solve this equation is to multiply the constant term by the inverse. So again, let me just reiterate that when I use the inverse of this matrix to multiply this side, so A inverse times A will give us the unit matrix, and then the unit matrix times x and y will end up giving us x and y. So we know what the answer is right here. So it's going to be x, y. And this is now going to be equal to, we're using the inverse, which is -1/8, 2, -3, -4, and 2 to multiply 11 and 10. All right, very, very simple. Now, again, we're not going to trouble our -1/8 just yet because we really don't want to create any problem as it relates to fractions inside there. So we're going to take down that -1/8 using the distributive law. We're going to map that to 11, and these will be mapped to 10. So let's go now. We're taking down the 2 and the -4, and those 2 were actually mapped onto, they were mapped onto 11. So I'm going to multiply those by 11. Plus, we're taking down -3 and 2. What did we map those onto? We map them onto 10. All right, so let's go ahead now. Bring back down our -1/8, yes. So 2 times 11 will give us 22, plus -30. -4 times 11 will give us -44, plus 20. Now let's work that out now. Very, very simple. So it's now -1/8 Now, 22 plus negative 30 will give us negative 8. Negative 44 plus 20 will give us negative 24. Now, at this stage, student, this is where now we use our inverted determinant to multiply each term on the inside. Now here, this is going to be negative 1/8 times negative 8. You realize that that will work out to give you a positive, because negative times a negative end up giving you a positive. But also remember that if I am multiplying by negative 1/8 is the same thing as dividing by negative 8. So this now would work out to give me negative 8 over negative 8 and negative 24 over negative 8. That's what x and y is equal to. So x, y, negative 8 divided by negative 8 will give us 1. Negative 24 divided by negative 8 will end up giving us 3. So there you have it. You would have solved the pair of simultaneous equations using the matrix method. All we need to do, step 1, write it in the matrix form if it is given like this. If it is given in the regular form and it's asking you to solve it using the matrix method, we write it in the matrix form. That's step 1. Step 2, we find the inverse of the 2 by 2 matrix. We find the inverse of the 2 by 2 matrix. Step 3, we use the inverse of the 2 by 2 matrix to multiply both sides of the equation. Both sides of the equation. We already established that when you multiply your left-hand side with the inverse, we know exactly what our answer will be. That would be the variable matrix that we have over there. So all we need to do now, since we know that that is what is happening, we use the inverse to multiply the constant term, and that's it. If you can multiply, then you will end up with the values for your variables. All right? So please take a pic of that, and then we'll be looking at another question. Right? So I will just clean the board, the entire board now, so that we can get a little bit more space to work with. Maybe I'm guilty in terms of my organization of the board. All right, so you have to just work with me, see with me as it relates to that. All right, so I have a very nice, lovely question here. All right, so here it says, use All right, so here we have it. Now, you might be wondering what is happening here, because we started out in the last session and this session with equations with only 2 variables in it, where we have x and y. But I want you to be exposed to a variety of questions so you understand clearly what to do if you should see a question of this nature. Now notice here that the equation that you're looking at here it contains 4 variables. All right, 4 variables. Now, all we're saying, students, is this: the equations would have been written in the matrix form already for you. Notice it's the 2 by 2 matrix times the variable matrix and equal to the constant terms there. All right. Now, how do we go about working this code? Now, the same principle applies. All I need to do is to find the inverse of that 2 by 2 matrix. The inverse of this 2 by 2 matrix here. All right. Now, when I now find the inverse of the 2 by 2 matrix, I'm going to use that inverse to multiply both sides of the equation. But you already know what is going to take place with the left-hand side. Good? We know the answer even before we do any work here. So let's go and let's now find the inverse of that 2 by 2 matrix. All right? So I could write it here. So the inverse, could we call this matrix B? Have been working with C all along, A all along. So B, let's call this C, and let's call this K. So makes life easy for us. So we could say B inverse is equal to 1 over the determinant, agree, times our adjoint matrix. Good. So 1 over the determinant times the adjoint. So let's go find our inverse. So it's now 1 over, now notice here, this is going to be 2 times 3. So it is 2 times 3 minus 4 times 1, or 1 times 4, times your adjoint, which we're interchanging the leading elements. We're interchanging the leading elements. Here, we're interchanging the leading elements. So this becomes 3 and 2. And we're multiplying the non-leading elements by -1. So this becomes -1, -4. So let's work that out now. We end up with 1. Now 2 times 3 will give us 6. 1 times 4 will give us 4. So 6 minus 4 will give us 2. So we end up with 1/2 of our adjoint matrix, which is 3, -1, -4, and 2. There we have it. That's now our inverse of that 2 by 2 matrix that we have there. Now, what is it that we're going to be using this inverse to do? You're correct. We're going to be using this inverse to multiply both sides of the equation. Both sides of the equation. But we already know, students, we already know, we have seen it, that if I use the inverse to multiply this side, then B inverse times B here is going to give you 1, 0, 0, 1. And then when I use that identity matrix to multiply the variable matrix, I'm going to get back my variable matrix as the answer. So what's the next step? Since we know the answer for that part, the next step is just to use our inverse to multiply the constant matrix here, this constant matrix here. Now, let us go now and do the multiplication for that part of it, okay? So we can go ahead and set up. So we know that we're going to have our variable matrix, which is R, S, T, and U. And this will be equal to the inverse times our constant here. So our inverse is 1/2, 3, -1, -4, and 2. We're going to now multiply here. So this is going to be 2, -1, 4, -1. Sorry. 1, good. negative 1. So we're going to be multiplying. Now, if you notice here, students, that we have two columns in this matrix, so our distributing will take place 2 times. So let us go now, not using the half. We're not using the half just yet. So we're going to take that down. Now, 3 and negative 4 will be distributed to 2, and later on it will be distributed to 1. While negative 1 and 2 will be distributed to 4, and later on it will be distributed to negative 1. All right, so very nice and simple. We're taking those down, 3, negative 4. So it becomes 3 and negative 4. What did we map it on to first? We map it on to 2. So both must be multiplied by 2. Plus, we're taking down negative 1 and 2. What did we map those onto? We map them onto 4. So that is 4 and that is 4. So yes, we're finished with that column. We're finished with that column, yes. So we need now to move over to the other column. So we're taking down 3 and negative 4 again. What did we map it to? We map them to 1, so that becomes 1 and that becomes 1. Plus, negative 1 and 2. What did we map those to? We map them to negative 1. All right, so when you're using the distributive method there, you just go about doing this stuff without even have to put a lot of thinking into it. So let's go now. So we bring down the half just the same. Open my bracket. 3 times 2 will give me 6 plus negative 4. 3, 2, 6 plus negative 4. Then here we're going to have 3 plus, no, negative 1 times negative 1 is going to give us positive 1. Negative 4 times 2 will give us negative 8, plus 2 times 4 will give us 8. Negative 4 times 1 will give us negative 4, plus 2 times negative 1 will give us negative 2. Here we have it, 1/2. Now 6 plus negative 4 will give us 2. 3 plus 1 will give us 4. Negative 8 plus 8 will give us 0. Negative 4 plus negative 2 will give us negative 6. Now, at this point, student, at this point, we are going to use now our inverted determinant, which is our scalar quantity here, to multiply each term on the inside. A half multiplied by another number is the same thing as that number divided by 2. That's what we're doing. So in truth and in fact, we just need to divide each term inside here by 2. So now, a half times 2 will give us 1. A half times 4 will give us 2. A half times 0 will give us 0. A half times negative 6 will give us negative 3. Now there we have it. R, S, T, and U. And that's now equal to 1, 2, 0, negative 3. Now notice here that the two matrices that we have here, they are 2 by 2 matrices, all right? So if we're saying that this matrix is equal to this one, then it simply means that the corresponding elements are equal. So R is equal to 1, S is equal to 2, T is equal to 0, and U is equal to negative 3. Very, very simple. All right. So yes, it looks unusual. I mean, that's not how we started off, but you must understand that it is possible that you could get a question with more than just 2 variables. All right. So I'm just going to take myself out and ask you to take a pic so you can have it to rewrite in your book. later. All right, good. Now we have one more question on simultaneous equation, and after which we will be able to just look at one question as it relates to equal matrices, all right? Solving problems with equal matrix. All right. Sorry about that. All right. So yes, this is our last question as it relates to simultaneous equations. So let's go. So nice question. It says express the equations, which is 4x minus 2y equal to 0 and 2x plus 3y equal to 4 in the form ax equal to b. 2, find the inverse of a, and 3, hence solve for x and y. Now this is something that by now we're all used to. We know exactly what to do. So let us look at the solution part of it. All right, so solutions. So part 1, we're going to now write the equations in the matrix form. So now notice here that the matrix A, again, would be the coefficient of the variables. So I'm going to have 4, 2, 2, and 3. And I will stop to ask you, do you think what I've written down is correct? Do you think what I've written down there is correct? All right, so for those persons who say no, I am in agreement with you, because when I look at the coefficient of this variable here, then the coefficient here is not positive 2, but it's going to be what? Negative 2. So in this case, we must bring the sign down there with it. So good. I appreciate that you're paying keen attention to what we're actually doing. So that is now correct. So our matrix X now would be X and Y. And this is going to be equal to matrix B, which in this case is going to be 0 and 4. All right, so there we have it. Good. So that's part 1. Now, going now to part 2, it says to find the inverse of A. So part 2, the inverse of A. So A inverse is equal to 1 over the determinant times your adjoint matrix. So let's work that out quickly. So that's now 1 over 4 times 3. I could just put down 12. We know what that is. Minus, notice here, negative 2 times 2 will give us negative 4. Our adjoint here now will be interchanging the leading elements. So you end up with 3 up there and 4 here. Multiplying the non-leading elements by negative 1. So that will end up giving us positive 2, and that would be negative 2. All right. Now here we have 12 minus negative 4. So the negative of a negative, it becomes what? Positive. So this is 1/16 of the adjoint matrix, which is 3, 2, negative 2, and 4. So there we have it. That's where we want to stop as it relates to the inverse. We're not going to use that inverted determinant to multiply what is on the inside just yet. So that's now step 2. Step 3, we're now going to have to solve the equation. Now, to solve the equation here, remember what we're supposed to be doing now is use the inverse to multiply both sides of the equation. Now, I know what you know, that the left-hand side will work out to just give you the variable matrix. We all know that already. So all I need to do now, students, is just to use my inverse here to multiply my constant term. So part 3, we have it here, part 3 will be xy equals to the inverse, which is 1/16 of the adjoint 3, 2, -2 and 4 times the constant, which is 0, 4. So this is now 0, 4. All right, so this is simple. We're taking down the 1/16. Remember, these two will map onto 0. These two will map onto 4. So we take down 3, -2. What do we map them to? We map them to 0. So both of them must be multiplied by 0. Plus, we're going to take down 2 and 4. What do we map those to? We map them to 4. So both of them must be multiplied by 4. So we have our 1/16. Let us now work out what is inside of our bracket. So it's 3 times 0 will give us 0 plus 2 fours will give us 8. -2 times 0 will give us 0 plus 4 times 4 will give us 16. So 1/16 of 8 and 16. Now, when I'm multiplying by 1/16, it's the same thing as dividing by 16. So this would be now 8 divided by 16. Please note 8 divided by 16. 8 into itself 1, into 16, 2. So you'll end up with a half. 16 divided by 16 will end up giving you 1. So right here, our answers would be x is equal to a half, while y is now equal to 1. And there you have it. You would have solved the pair of simultaneous equation there. All right. So take a pick and then just let's wrap up the session now with a question on equal matrices. All right, very good. So let's go now. No, I'm very, very, very confident that as it relates to equal matrices, that all you students out there in TV land would be able to work a question even if it was not demonstrated to you. Why? Because you'd have learned every single thing that you need to know. All you need to do is to apply them. All you need to do is to apply them, and then you would be able to solve a question that involves equal matrices. But let us just look at one here. We start out with the matrix A, and the matrix A is equal to 3, 5, 1, and 0. The matrix B is equal to 6, 4, -1, -2. And we also have a matrix C, which is equal to R, -8, 4, and Y. All right. Now, what is it that they're asking you for? It says calculate the matrix product AB, matrix product AB. So calculate the values of R and Y given that 2A plus C is equal to AB. All right? No, so that's your equal matrix question. Now, let me just say this to you. When it comes down to equal matrix, two matrices are said to be equal if they are of the same order and the corresponding elements are equal. Two matrices are said to be equal if they are of the same order and corresponding elements are equal. Good? So if I should give you A, and I tell you that A, let's not use A since we have A up there already. Let's use D, and I tell you that D is 1, 2, 3, 7. And I say P is equal to 1, 2, 3, 7. If I tell you that D is equal to P, you would know, agree with me. Because notice 1 corresponds with 1, 2 corresponds to 2, 3 corresponds to 3, 7 corresponds to 7. So D is equal to P. All right. And they are both 2 by 2 matrices. All right. So two matrices are said to be equal if they are of the same order and corresponding elements are equal. That's what we're saying. Now, let's look at the question at hand. All right. So we have A, B, and C. Now they ask you to find AB. Notice AB is your general multiplication. That should not be a problem. We already know how to do that. So let's work that out. So AB is equal to, we start with A, which is 3, 5, 1, and 0, times B, which is 6, 4, -1, and -2. And we're now going to have to multiply. Now remember, we're using the distributive method. So map on to 6, map on to 4 later on. These two, map on to -1, map on to -2 later. So we take down 3 and 1. 3 and 1. And it was mapped onto 6 first. So that is 6. And that is 6. Plus 5 and 0. What did we map that onto? We map that onto -1. -1. Then we're going to now take down 3 and 1 again. We map those onto 4. So that's 4. That's 4. Plus 5 and 0 map onto -2. -2. Great. So let's now work that out. So this becomes 3 sixes, 18, plus -5. This becomes 12 plus -10. Here, this becomes 6 plus 0. This is now 4 plus 0. Therefore, AB is equal to, this is going to give us what? 13. This is going to give us 2. This is 6. And that is now 4. Now, that is what AB is equal to. All right, so AB is 13, 2, 6, and 4. Good, so we know what AB is equal to. Now, our next task is to solve for R and Y, given that 2A plus C is equal to AB. 2A plus C is equal to AB. So we're going to write that down right here. 2A plus C is equal to AB. Now, from our previous class, we know that this 2 here, it represents a scalar quantity. All it is saying to us is to use this 2, the scalar quantity, which is 2, to multiply each element inside of A. That's all it is saying. So let us now just write it out. So this becomes 2 times A, which is 3, 5, 1, and 0, plus C, which is R, negative 8, 4, and Y. And this is now going to be equal to AB, which is the matrix that we found right here, which is 13, 2, 6, and 4. All right, very, very simple. So what it is saying here now is that if I work this part out, if I work my left-hand side out, it is going to be equal to what is on the right-hand side. So let's work that out and see what is happening. So 2 times 3 will end up giving us 6. 2, 5 is 10. 2 ones, 2. 2 times 0, 0. Plus R, negative 8, 4, Y. And this is now equal to 13, 2, 6, and 4. Now also we learn about the addition of matrices. The addition of matrices. Only matrices of the same order can be added, right? And we add corresponding elements. So 6 corresponds to R. 10 corresponds to negative 8. 2 corresponds to 4. And 0 corresponds to Y. So those are the elements that we're going to be adding. So it becomes 6 plus R, 10 plus negative 8, 2 plus 4, and 0 plus Y. Now, this would be equal to 13, 2, 6, and 4. Now, students, this is one of the common mistakes that students tend to make, where they have 6 plus R and they write it as 6R. All right? 6 plus R is 6 plus R. You cannot have 6R there because these two terms are not alike. So 6 plus R is equal to 6 plus R. Good. Now, let us just now simplify this part here. So this becomes 6 plus R. That now becomes 2. This becomes 6. This becomes Y. And that now is equal to 13, 2, 6, and 4. Now, notice here that we end up with a 2 by 2 matrix, which is said to be equal to a 2 by 2 matrix. Good? Now, in this case, what we're actually saying is that corresponding elements are going to be equal. Corresponding elements are going to be equal. The elements that are in the same position. All right? Now, notice here, we don't have a problem with 2 because it corresponds to 2. Good? 6, it corresponds to 6. Simple. Y would correspond to what? Very good. 4. So we know for sure that Y is equal to 4. But also 6 plus 6 plus R corresponds to 13. Now, some of you would be able to just look at it and know what R is. Some might not be able to do it like that. What we can do is just to write the equation here, which is now 6 plus R is equal to 13. We can just go ahead and solve for R. So R is going to be equal to 13 minus 6. Therefore, R is going to be equal to 7. Very, very simple. And if you notice, this question now becomes very, very simple because you'll have done general multiplication, you'll have done scalar multiplication, you'll have done matrix addition, and you'll have learned already about simple equation. So this question is quite simple, as you would notice there. Now, this is as far as we go for today's lesson. So all I can do now is just to encourage you to keep on practicing as it relates to matrices. All right, very, very nice topic. And when you understand the topic, it makes life easy, it makes math become alive and fun. So just go ahead and practice. Until I see you all performers for our next lesson, where we will start looking at the vectors. Very nice, lovely topic. As students would normally say, you will only see that because you're a teacher. But you will enjoy it just the same as how you enjoy matrices. So I look forward to seeing you again at the next session. Take care now and be safe.